Today we are going to discuss about one of the most important application of linear filter in the beam forming applications. So when we say the beam forming, what do you mean by the beam and the formation of the beam? So when we say the application of adaptive filters are widely used in many fields. There are many fields this has been used and has emerged to find the minimum amount of noise that are present in the signal. The purpose of this multiple beams towards any kind of a users is nothing but reducing the effect of the distractions or distortions or the interferences. In other words, we call them it as a noise for the wave vectors. So when we say the effect of adjustment or to completely remove, what kind of approaches we need to go for it, and is there any kind of approaches may leads to go for this beam forming approach for the eradication of the interferences present with the help of noise formation. I can say noise cancellation. So it is nothing but, so in general, if you want to see what is beam forming, it is nothing but to reduce, it's a technique used to improve a signal. The signal is nothing but the input signal into noise ratio of this received signal. And if there is any undesirable, because manually we know if this is the input, this is what we are expecting. There must be some undesirable interferences, sources, some kind of a focus of the transmitted center, the specific locations, if there are there, then we need to look into it and we'll try to avoid those things. So such cases we find that beamforming applications are essential, and it is central to the system with having a sensor of arrays, including the communication systems which are supporting the latest 5G and LTE and LAN. There are different types of beamformings we have been using. So they can be of analog form of beamforming, a digital beamforming, or some way we call them it as a switched or adaptive beamforming. So many types are available, but here we are going to look about the digital formation of the beamforming form. So general principle, if you see, we will have a multiple antennas to control the direction of the signal approximately, and we'll try to see the magnitude and phase of the individual signal, whether it is going to have any kind of a match with the an array of multiple antennas. So the analysis of the individual one will give the better performance when we go for finding out the collective measure together. This is what we are going to see in the case of beamforming. The benefits, if you see, the one important thing is nothing but the spectral efficiency of the input signal or any kind of a signal will be increased and try to give which in turn serves as the better SNR ratio. Hardware complexity, if you see, it is there high due to the use of, because we are going to use multiple antennas or multiple beams, so obviously this will be there, but at the same time we can reduce the effect of the repairment, troubleshooting and the repairment of analysis. That will be much less compared to other approaching system. So that is what we are going for this form. So here the main important thing is something, but you try to see and try to map the input signal and see whether the weighted vectors are being adjusted with your phase and the magnitude of the input signal, and if they are weighted, sum is resulting in the form of array of output yn. So because we are having multiple inputs, so multiple inputs followed by their incoming phase and amplitude signals are combined together in order to get a single output. So the combinations and the merging of all these informations together will in turn play a vital role in formation of this approach. This is what the systematic view or the systematic approach is of keeping this. So we need to have a kind of an approach there. So the approach is nothing but here. So normally we will have this as a single, but here we will be receiving it through multiple antennas. So multiple antenna will be combined together and the output will be fed as an input to the expected output. So this y of n is nothing but some kind of a measured output which will be getting at the x of n signal. So this x of n will be passed on to the multiple antennas and then have a logic, the weighted parameters with the weighted vectors from the adaptive algorithms, and the sum of these weighted as along with the input combined merging of these combinations will give you the expression as y of n. So the expected output E of n will mainly depends upon these weights, the inputs and the y of n. So adaptive algorithm is again, the adaptive process we have been using here is only for the purpose of minimization of the errors between the desired signal and the array of output yn. The complex weights wk for the antennas elements are carefully chosen in such a way that if there is any peaks and nulls are there in the radiation pattern of the array will be ignored. The weight could be then slowly varied to steer the beam until the maximum signal occurs at the direction of the source is formed. Linearly constrained LMS least mean square algorithm is most commonly used algorithm for the case of simplicity, and it requires only the knowledge and the bandwidth of the sigma. So these are all some formation of analysis which we could able to find out in the analysis. Fine. Can we go ahead? Thank you.